Aha, here's our patient. The patient has received all known antibiotic treatments to no effect. In conclusion, either he is not ill, or we have a new strain of microbes.
Or this could even just be a case of resistance to antibiotics. Let me explain. When the body is infected by bacteria, it attempts to defend itself in several ways, by increasing its temperature, but mainly by using its immune system. As soon as a foreign body enters the organism, it's detected straight away and alarm bells ring. Lots of white blood cells come along to identify the culprits and get rid of them. But sometimes these defenses are overwhelmed by bacteria. That's when the illness really begins. Luckily, since antibiotics were discovered, we can help patients protect themselves. These drugs destroy most bacteria or create a hostile environment for them. Antibiotics soon became a quick-fix solution. For the slightest scratch, a course of antibiotics. It was so effective in preventing infections from developing that the use of antibiotics increased. They became widely used to treat battery-farmed poultry and pigs. But before long, the illness returns. And antibiotic treatments suddenly stop working. What happened? Well, before bacterial cells divide, they duplicate their genetic material. This material is composed of DNA. Portions of the long molecule can hold precise information on the activity and development of the bacteria. These portions are what we call genes. Each gene is composed of a sequence of 4 elements, called nucleotides, of which 2 are always matched in pairs because they're complementary. As DNA is copied very rapidly, errors in the copy frequently occur. These errors are called mutations. Most of the time, these mutations are of no consequence, but sometimes they can be harmful to the bacteria. However, with such a high number of mutations, some of these copy errors can result in resistance to antibiotics. When in contact with the antibiotic, the resistant bacteria will be the only ones to survive. In fact, the drug will have chosen the resistant strain. And then, since there is no longer any competition for food, the bacteria can multiply very fast. It's exactly like natural selection. Individuals with the most favorable characteristics reproduce more than the others and will be able to continue to evolve. Indeed, with antibiotics, we are reproducing what nature did 4 billion years ago that led to the evolution of species.
Well, miss, are you demonstrating here that the patient is suffering from acute Darwinitis?
You could say that.
Aha, that's exactly how I see it. Gentlemen, this case is very interesting. Let's move on to something else.